Now I'll be looking at numeric series which appears in reasoning. So it's from the domain of reasoning. The questions are pretty straightforward. There will be some numbers which will be given to you, which would either be in the increasing order or the decreasing order, or maybe it could be in some mixed pattern. You have to figure out what this series is all about, what is the common logic that connects all these elements. So series is nothing but one will come after the other, after the other, after the other, and so on. So you have to figure out how these elements are arranged, or why does this particular element come after the first element. Okay, so that is something that you have to take care of in these series. Once you understand the logic, then either you would be asked to find the nth element or something which replaces the question mark, or you will have to figure out the incorrect element which is present in an existing series. So the questions could be either of these two types, but the basic thing remains the same. You have to understand the logic in which these numbers are arranged, and what exactly would be coming after this entire series is done, or which one would be an incorrect element which does not really follow the pattern which the other elements are following. So that is how it works. So there are a couple of things that you can do. One thing is, of course, the usual things hold true. The things you need to know is nothing but the squares of numbers from 1 to 30. So 1 to 30 you need to know the squares. 1 to 12 you need to know the cubes. 1 to 15 you need to know the reciprocals. So these three things are given when it comes to solving series questions, because most of the time the logic will involve either of these three things. Either it would be squares or cubes, or it will be reciprocals. Also, it's better to know what is 1 factorial till at least 8 factorial, if you can remember that. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial 120, 6 factorial 720. Till here almost everybody knows. 7 factorial will be nothing but 7 into 720, which is nothing but 5040. 8 factorial is 40320. So if you remember till 8 factorial, then probably you should be good to deal with these questions. So this is the basic knowledge that you need. The questions could be of two types. If I am speaking broadly, the questions could be of two types. The first type says that the series is connected by some superficial logic. It has some trivial logic like differences or multiplication with some reciprocal or some progression that is being followed or something like that. The other type, which is the trickier one, is probably, if it's a 5 question set, then probably you find 1 or 2 questions which come from these areas, which are very difficult to crack in an exam scenario unless you have an eye for detail. So if say for example, if there is a series in which each preceding term has an addition of a factorial, a square and a cube, that becomes very difficult. So if say for example the first term is 1, okay, square of 1 is 1, cube of 1 is 1, 1 factorial is 1, so 1 plus 3 will give me 4. Okay, the next term will have square of 2, that is 4, plus cube of 2, that is 8, that is 12, and 12 plus 2 factorial, that is 2, so 14. So the third term will be 18. Now if you look at it, it becomes very difficult for you to understand. If you look at the fourth term, it will be even more difficult. So you will have square of 3, that is 9, cube of 3, that is 27, so 36, 36 plus 6, that is 3 factorial is 42, plus 18 is 60. Now if a series like this is presented 1, 4, 18, 60 and so on, it becomes almost impossible to figure out what this entire thing is. And there are a few questions, a couple of questions at least in every paper, which will be of some obscure logic, which will have some obscure logic, which are better left alone. You cannot really sit and fight it out during the examination and then figure out that 42 is nothing but 9 plus 27 plus 6. Now that is extremely far-fetched to understand. And so somewhere down the line, an aspirant has to give up during the test. If 1 or 2 questions are there which you cannot do, it's better to eat the humble pie and move on with the next question. Okay. So the second part which I explained is difficult. The first part, of course, if you know arithmetic progressions, how terms increase in a particular sequence, you are good to go. Even if it's a geometry progression, you are good to go. If it's squares or cubes or remainder or reciprocals or factorials or sum of the number and square of the number, sum of the number and cube of the number, or so on, it's very easy. Sum of digits is something which is a very common question which is being asked, because if say for example, if first element is say for example 12, the second element will be nothing but 12 plus 1 into 2, so 14. Third element will be 14 plus 1 into 4, 18. Third element will be 26 and so on. So that is one series which can, something like that can come. So there are infinite ways in which you can make series. That there is, you cannot say that you have mastered all the ways of making series. You will find a series which will stump you. So there are infinite ways of making a series, and of course it's a good practice to understand at least the top 5, 10, 15, 20 ways of making a series. If you have encountered 20 to 30 different series, you will figure out that you can solve at least 3 questions out of 5 in any given paper. So that much of practice is required, and if you have that much of practice, then you should be good to go with regard to series. Okay. Now series can be of 2 types or probably 3 types if you can add the random version as well. But I would say the predominantly found or predominantly common series types are either increasing series or decreasing series. Okay, there could be a mixed series as well, which is again it comes into the domain of the second part that I explained, which will have obscure logic. So we cannot really be relying on that knowledge. But at least ascending series and descending series have some method which you can follow so that you get answers to your questions. Okay, so whenever you get an ascending series or a descending series, what you can do is, first thing, you will take the difference between 2 consecutive terms. Okay, and you will see if there is some relation possible. So differences come at various levels. You will have a first degree of difference, second degree of difference, third degree of difference, and so on. Ideally, if you go till second or third degree of difference, you should be able to figure out a logic. If you are not being able to figure out a logic, then the logic does not lie in the difference between those 2 terms. In that case, you have to take ratios of consecutive terms. If A, B, C, D, E are in series, then you have to take ratios of B by A, C by B, D by C, and E by D. That has to be done. If you are not able to figure out a logic by using ratios as well as differences, then probably that series has some obscure logic which you will not really be able to crack in the test scenario, and so it's better to give it up. Okay, so whenever you see a series, first thing you will do is take differences. If that doesn't work out, second thing you will do is take ratios. If that also doesn't work out, you will see if there is something which is present which has an overlap or something, and if you cannot figure anything out, then probably we will move to the next question. 3 out of 5 is a perfectly good outcome when it comes to series, because once you crack the logic, it's very easy. And to crack the logic, if you cannot do it in the first 15-20 seconds, then it's very difficult to crack it in the next 1 minute or so. So once you have invested 20 seconds, you are going nowhere. It's better to skip that question and go to the next question, because time is at a premium here and you cannot really waste time thinking about series. Okay, so these are deceptively simple questions. Nothing, no knowledge is required. Even a lay aspirant can come and sit and probably try to crack series, but then again, if you are trained, then probably it will be quicker for you. You will save those 15-20 precious seconds which a lay aspirant might take to decipher the series. Okay, so I will just go through 3 series and we'll try to figure out what kind of logic might be present, or what kind of logic is present in a numeric series. And by the end of it, probably things will be clearer to you. You will be able to appreciate how a series is made or how a series should be solved. Okay, so the direction says that in the following number series, only one number is wrong. Find out the wrong number. So this is a very straightforward question. The series is given, so do not really have to find out the next element of the series, but you have to figure out which element is wrong. Okay, so you have to be very careful when you are reading the instructions, because in some cases you might have to perform some other operation on that wrong element. Okay, so if one element is wrong, you will have to perform some other operation and then you will have to come out with the resultant. You should not write the element as it is if it is given in the instructions. This is pretty straightforward, so we will simply pick out the we will simply go through the logic and then we'll pick out the element which does not fit in that entire group. Okay, so there are 3 questions. I will solve the first 2 questions and the third one you can try out for yourself. So the first question states that 5, 348, 564, 689, 716, 780 and 788. So it is an ascending order of series. So 5 is 5, something is added to 5 or something is multiplied to 5 to give 348, then 564, 689 and so on. Now the first thing that you can notice is that 5 and 348, they are quite far apart. Okay, so 17 to 5 is 340, so this is somewhere close to 69 to 70th multiple of 5. Okay, but this on the other hand is not even, it's slightly more than 1.5 times 348. So the number is drastically coming down. So this cannot really be a multiplication series. So that is something which you have to imbibe in yourself. As soon as you look at the question, you should be able to get this inference. You should not really waste time in taking ratios. But as you have said before, probably you will simply take differences and then you will write this thing. So it's better to take positive differences right at the start. So 5 and 348, the difference is 343. So I will write 343 here in between these 2 elements. If you look at 348 and 564, 348 plus 52 is 400, plus 100 is 500, so 152 and 64, so 216. Now as soon as you write 216, you should be able to figure out what the series is, because 343 is 7 cube, 216 is 6 cube. If you know the cubes of numbers, you should be able to figure out the series as quickly as in the second difference or even the first difference if someone is really observant. Now 564 is present and 689 is present. So 564, 74 and 84, then 5, so 25 and 125 is the difference. So on, so far so good. 689 is present, 716 is present, so the difference is 11 plus 16, that is 27. 716 and 780, it's nothing but 64, and 780 and 88 is nothing but 8. Okay, so if you look at the series, you can find out that the difference is nothing but cubes of numbers. Okay. So 5 plus 7 cube is 348, 348 plus 6 cube is 564, 564 plus 5 cube is 689, 689 plus 4 cube should be present, but this is not present, so 716 is incorrect. Okay, so it should have been 689 plus 64, which would have given me 753, and 753 plus 27 would have given me 780, 780 plus 8 gives me 788, so the rest of the series is fine except 716, so that is our answer. Okay, so if you know the cubes of the numbers, this was a very easy series for you to figure out how to solve this thing, so it was pretty easy. Okay. Now we'll go to the second question. The second question says 4444. Second element is 2224, 1114, 556, 281.5, 142.75 and 73.375. Now if you look at this very carefully, this is 4444, 2224, which is almost half of this, 1140, which is almost half of this, 556, which is almost half of this, 281, which is almost half of this, and so on. So we can figure out that there is a ratio of 1:2, but the exact half of 4444 is 2222, but it is given 2224. Okay, so we know that there is some factor of 2 involved here, and they have added 2 here. Now if you look at this 2224, if it is present, if you divide it by 2, you will get 1112, and again 2 has been added. So if you have an eye for detail, you will easily figure out that this is nothing but element divided by 2 plus 2, element divided by 2 plus 2, and so on. So 4444 divided by 2 is 2222 plus 2 is 2224, which is here. 2224 divided by 2 is 1112 plus 2 is 1114. 1114 divided by 2 is nothing but 2 5s are 10, 2 5s are 10 and 2 7s are 14. So 557 plus 2 should be present, so this should be 559, but this is 556, so we will hold on to that thought for a moment. Now 559, if it's present, if I divide it by 2, I will get 2 2s are 4, 2 7s are 14, 2 9s are 18, 0.5 plus 2 will give me 281.5. So this is perfect. Again 281.5, if I divide it by 2, then I will get 2 1s are 2, 2 4s are 8, 0.75 plus 2 will give me 142.75. 142.75 divided by 2 will give me 2 7s are 14, 2 1s are 2, 2 3s are 6, 2 7s are 14, 0.375 plus 2 will give me 73.375. So the rest of the series is correct and only 556 is wrong, so that is our answer. Okay, so this was a slightly complex series in which you will have division as well as addition to consider. So you can see that this is a decreasing series. Decreasing series, again you will try to take differences. If something is obvious, then you will move along that method. So in the first series you saw that the multiplication would be reducing drastically. So 72, then 1.5, then again it's 1.25 or something and so on. So it decreases radically once you move past the first element. So multiplication cannot really be the answer. There has to be something which relates to difference. And that was your first loop, because so that you have to take difference. In the second question, it was very obvious that 4444 and 2224 are related such that if you divide it by 2, it will be the same thing. If you divide any element by the previous element, you will get half as the answer, or if you divide any element by the preceding element, then you will get 2 as the answer. So it was pretty obvious in this case as well. And once you have an eye for detail, you can easily solve these questions. You can try question number 3 as well. It has a nice logic present to it. So if you can solve these questions, then probably you should be able to solve at least 2 to 3 questions out of 5 questions in series. Again, it is highly recommended to leave those questions which are not able to solve, because they will take a lot of time. If you cannot crack the logic of a series within 20 seconds, it is very difficult to crack the logic of that particular series in 1 minute. So remember this thing and beware of obscure series which are present. So 1, 4, 18, 60, if that is present, then probably it's a good idea to skip that series, because there is a high chance that you will not be able to figure out what exactly to do with this series. So it's better to let go of those questions and better to do other questions in the time that you have. And you can, if negative marking is not present, you can guess answers to this series. and get done with it. So I hope this clears a few doubts regarding numeric series. You can look at our other videos as well for other topics. Thank you.